Hello guys, welcome to my video. This is the teardown of my first Dualsense and refurbishment. This is just the case. I just put it to one side with all the screws in there. It's when you get these apart, it's worth checking whether your battery is nice and flat. If it's got any signs of bulging, you know you've got a battery problem. So this one was fine, and it was fitted with Skull and Co overcaps, which I had to peel off to remove the main sticks, and they had been suffering from sticky rubber syndrome, so I cleaned them up a little bit and then wiped off the residue of the alcohol, because that might keep it going, the sticky rubber degradation. Right, next, come on, which way? Why won't it move? Zoom right out first, that helps. Nope, nope, get your act together, come on. Right, that's it. What we got? The main things to avoid when taking these apart is you've got one teeny weeny ribbon cable left and right of the jack down here. One there. They need to be decoupled delicately. They are very delicate. And then you've got three other ribbon cables. One there. Decouple them and desolder both sides of the motor wires is a good practice before you start taking all the screws out on the battery tray board. Right, what is this? Left stick, axis O or 0, and it had worn worn track assembly. That's the track, and the metal contact is the wiper. Track, wiper, yeah. And that's the wiper. As you can see, it's got all the black residue, which is all of that missing black from the contact smudged around it. So that was messed up, and that is why the result in the first video was sketchy on the left stick, moving it left to right. It was jumping all over the place. This is the TMRs I'd sourced, which are labelled thus: LT-5J. I don't know what the 5J is, but I think the L and the T, you've got L's and you've got R's. In the Dualsense, there are only L's. It's something to do with the pin arrangements, the current flow. Left to right, right to left, and all the rest of it. They used 4 of the same in the Dualsense. For the DualShock 4, it's one side is different, and the same with the Xbox. The Xbox is reversed to the DualShock 4, and then the ohms resistance value is different. I won't go into that. These are, what are these? 2.3k resistance, programmed, probably TMR chipsets. So that's the T on the labelling is probably TMR. I'm only guessing. Right, what do I do here? Yeah, I flow fresh solder over those three, and the opposite side, of course, and then we get my solder sucker on there, heat them up and try to suck it all out, and then put another fresh load of solder on them and wiggle the base pot once they're in this position here. Once they're peeled off and pulled forward and you're not clashing with the axis rotational pivot on the main pot, it makes it easy to pull it out. And you've got to be careful with your soldering iron that you don't press it against your terminals. Cable, these things, you can melt them. That was them dry fitted, pushed back and tested that they were all moving freely before you do any solder work. And this is the through holes. They have not been soldered yet. what can I say about them? Yeah, and if you get trouble with desoldering and using the solder sucker to make these holes clear so that you can actually get the pins in there, there is a method of using a damp toothpick. So you get all the heat on there and then force the toothpick in the hole with the metal still liquid, and then when it's cured you pull it out and you've got a maximum clearance hole for your pins to go back in there. And as you can see, the rumble motor terminals, the bottom one is located with an R stamped near it, that one there, and that is denoting red of the two motor wire rumble motor cables, as seen, all soldered up. And you can now see the location of all the ribbon cables that may cause you trouble, mainly that one and that one being stupidly delicate. You can tear them to bits. And what's this? That one there is a touchpad, and the two on the sides are for the trigger assemblies with the worm gears and all the rest of it in there, the haptics. This was the recalibration values of the Drift Guard app, which is a paid app to get it to do permanent recalibrations. Nominal value is about 6.66, so it's like 6 to 7%, closer to 7% nominal circularity recalibration on that app. But the standard calibration from the factory is roughly about 10.9% for your circularity. So if you want games like what's that football one with a stupid little car, Rocket League, that's the one. I hear of people having trouble with Rocket League. If they calibrate their new sticks to a 0 value, you cannot get your diagonal game control sensitivity to pull off certain moves and flips. You do not want it at average error 0.00. It's just stupid. Don't do it. And even 6.66 might be low, but I calibrated mine to a silicon sleeve. Soft rotation calibration to a silicon sleeve, and you can get a little bit of overpressure on the silicon sleeves, and then this is what the overpressure achieves in rotation. You can get back up to that 10.9 that I said was nominal. So you will be able to hit all of your move sets in your games. So this is a hard rotation representation on silicon sleeves, stick sleeve protectors. And this is removing all of the silicon sleeves to see what the actual value equates to, and it's 13.4. so I must have been rotating the left stick harder than I rotate the right stick with my thumb pressure for some reason in the hard rotation test on the silicon sleeve. If you're all still following me, this stuff is quite complicated, but hopefully I have decomplicated it. Right, so 13.34 was the left stick average error, and that's no silicon. So this screen, I did a calculation, I minused the 6.67, which would be the Drift Guard program, and that is equal to 6.67, which told me that the silicon itself has an offset of about 6.66%. So I worked out the thickness of the silicon, the offset of the Drift Guard program, all in one there. And this is the silicon tubing. So it depends on the silicon tubing you buy. They may not all be the same thickness, and I think it was about 0.3 millimeters, something like that, when I measured it. And it's got a squishiness value to it, as you can imagine. So you can get overpressure. Right, so that's silicon sleeves, and then the set at the front. Let me just go to the next screen to explain that. That is, I think that's a 1.2 millimeter drill bit, And then you've got concave and convex caps with my custom made centre silicon infill that I moulded from old sticks with the hole in the middle. So there and there. They're just a feature of what I like, because it allows me to put a screwdriver down the middle and use my bolted connections for sticks. They're super custom stuff. You don't need to know about. So they're a residual detail. They could be solid infill caps, but they don't need to be for the sake of what I do. So that's the Skull & Co caps on. And if the rubber underneath is perished, I would have fitted this set. And this is all of the crap that come out of it. I just boxed it up. So that's it. That's the end of that. Hopefully that clears up a few of the details. Yeah, 10.9% is the average error of a standard pad in the circularity, and you double that and you get a full unhindered pot range, which was what? Oh, was it 21.8? Can I count? 10.9 times 2 is 21.8. Yeah, something like that. Right, that's enough waffling on there. One more video to go, which was the final result test. This is the middle video. This is 2 of 3. Thank you for watching.